throw some light on regression. Then later we'll look at both correlation and regression analysis. Now, when we talk about regression, we are saying we are talking about trying to make predictions. Okay, predictions based on a mathematical model built from what? Empirical data. Okay, and so we've collected data from the lab, and we want to see, okay, whether the current, okay, is related to the resistance, or whether the resistance, okay, can help us to predict what the current or the potential drop in the circuit. Okay, such is an empirical data, experimental data, which you pick from the lab or even from the field. Okay, and then based on this, we want to run a prediction. So what if this value is this? What if we set this value to this? What will happen to the current? Okay. Then regression helps us to do that. So as long as there is a linear pattern between the two variables under consideration, we can fit a linear, okay, model to those two variables, which can help us to predict the value of one given the other. Okay, now what we need to know is that under the two variables, one is referred to as a dependent variable. Okay, one is referred to as a dependent variable, and that is usually your y, the dependent variable. Okay, this depends. Okay, dependent, the dependent variable, and the other, which is x, is your independent variable. The independent what? Variable. Okay, so for example, your performance in an exams, okay, and then the time you spent learning. Your performance depends on the time you spent learning. So your time will become your independent. Okay, time is the independent, but performance is what? The dependent what? Variable. Okay, so we can write an equation like this. Okay, in terms of prediction, we can say that the predicted performance, okay, the predicted performance always has a cap here. It's equals to some constant b naught, okay, plus what? Or let me change the b naught for the sake of this class. So a certain constant a plus the coefficient of the independent, which is b, times the independence, which is what? Which is time itself. Okay, good. So this is written like this mathematically. We usually write y cap is equals to a plus what? Bx. Okay. So linear regression is about fitting a linear model which can be used to what? Predict the value of the dependent given the value of the independent. Okay, now so the key question is, how do you obtain your a, and then how do you obtain your b? Okay, and these formulas are generated from the least squares what? Equation, okay, which are built on the derivative or differential equations. Okay, good. Now the solution to such a system is your a is given as what? Summation y over n minus b summation x over n. And then your b is given as n summation xy minus summation x times summation y over n summation x squared minus summation x all square. Okay, that is how you get the equations for the model. Okay, So with that in mind, we're going to take an example and then use the formulas to solve, right? So let me bring our formulas which we need. Let's just copy the formulas briefly here. Okay, no need, no need. We'll still manage without them. So it says, given the following observations were randomly selected. Okay, this time you have been told this is X and then this is Y. But usually in questions, you just be given a statement that maybe the temperature amount of energy depend on the heating temperature. Okay, so which means that energy becomes your Y and then the temperature becomes your X. Okay, but here you've been told that X, giving the data for X and the data for Y. Okay, so and you're asked to determine a linear regression equation or a linear equation which can be used to model the process to determine the value of y cap at x equals to 6.5 and to determine the coefficient of variation and interpret the data. Okay, now this is quite simple to solve. All you need to do is first, let's take this up a bit. First, you have this table here. Okay, so I'm going to edit it a bit so we have all the questions and the solutions on a page. So we have this here, right? The formula says that to get your beta, okay, B here, let me put it up here. So your beta is what? N summation x y minus summation x times summation y, okay, over what? N summation x squared, okay, minus summation of x, okay, all square. Good. So which means that we'll need to have x times y, okay, a column, a row of x times y. We also need to have the summation of x, the summation of y, and then we also need a row with x square, okay. So we're going to create additional rows and you help me out, so get your calculators with you. Let's create some additional rows here. So yeah, we're going to so we have x, yeah, so we're going to have what, maybe we should have sent it a bit down. So let me click over here. So we set the row down. We'll need another row which will be x square, okay. Yes, okay. So first we're going to have what, let's type this here. So this will give us x times what, x times y, okay. X times y will give us 4 times 4, which is 16, 5 times 6, which is what, 30, 3 times 15, 3 times 5, which is what, 15, 6 times 7, which gives us what, 40 what, 42. Then sorry, 42 here. Then 7 times 10, which gives us what, 70. Okay. Then next we're going to have x square. So x square will be what, 4 squared is what, 16, 5 squared is 25, 3 squared is 9, 6 squared is 36. 10 squared is what? Is 100. Okay, so let's find the sums as well. So I'm going to insert, okay. So we insert a column to the right. Okay, so summation x, we're going to add this. That will be what? 4 plus 5, 9 plus 3, 12 plus 6, 18 plus 10, 28. Okay, then we come here, summation y. We will 4 plus 6, 10 plus 5, 15 plus 7, 22 plus 6, 29. Then we come here, we do the same here. So we have 16 plus 30, that's 46, plus what, 15, that gives us 61, plus 42 should give us 103, plus 70 will give us 173. And then next we have what? Summation x squared. Okay, so 16 plus 25 will give us what? 41, plus 9 should give us 50, plus 36 should give us 86, plus 100 will give us 186. Okay, so what's next? I think we already quoted a formula for beta b, so let's code this. So a is also a summation y, okay, over n, minus what? Minus b summation x over what? Over n. Okay, good. So we'll find a value for beta. B is what? Your sample size. We have pairs of sample is 1, 2, 3, 4, 5. Okay, so n is 5. So we have 5. Summation xy is what? 173. Yeah, this is why I'll need your calculators. Summation x is what? 28. Let me write that well. So that is 28 times summation what? Y is 29. Okay. All over 5 times what? S squared is 186. Okay. Minus what? Summation x is what? 28. Okay, 28 square. Okay. So do the calculation for me, give me the answer for B. So one person should give me the answer for B. Yes. What's the answer? What's the answer? Prince, what did you get? Prince, what's your answer? Oh, summer class. Can I have some answers? What are you
Yeah,
getting?
sorry, I am driving, so I'm still not home. So I'm just following using my phone.
Okay. Yeah, can I get answer from somebody else? Johnson or Stanley, can I get some answers? Okay, it appears nobody is working. So I'm just going to assume some values and then proceed with my calculation. Okay. Yeah. So for this beta here, once you solve the value, maybe you get 6.2 here. Okay. Take note, this is not the actual value. It's just an assumed value. So we have 6.2. Okay. Then you repeat the 6.2 here as well. Okay. And then multiply with what? 28 over 5. Okay. And I'm sure once again, if I ask you for the answer, you're going to delay. So let me assume this will give me about maybe 5.1. Okay. Yeah. So once we've obtained those answers, okay, you can write your model as what the estimated y value, okay, is equals to negative 5.1, okay, plus what 6.2 of what of x, right? So this will be the linear model which can be used for the prediction. Okay. So if I ask you to determine a linear model which can be used, that will be the regression model. And then to determine the value of y estimate when x is 6.5, means you are just going to substitute the value of x, which is 6.5 here, okay, which will be what? Negative 5.1, okay, plus 6.2, 6.2 times what? 6.5, okay.